And we are back. It's been a while since we had a video, but we are back at them with video 3.9 on exponent rules. We went over multiplication and division yesterday. Today we are doing what is called the zero rule, the negative exponents, and what the power rule is. So get your notes ready. We have a few examples to go through. So first, just get down your definitions of what all the rules are. So with zero exponents, I mentioned this on Tuesday, but anything to the power of 0 is 1. So x to the 0 power is 1, 5 to the 0 power of 1, negative 1,284 to the 0 power would be 1. So anything to the power of 0 is 1. The power rule, when exponents are raised to another power, you multiply the exponents. So we worked on adding exponents when we're multiplying terms. Today we're raising a power to a power, and the reason that we multiply the exponents, so if we were to look at this problem right here and you have x to the third to the second power, if you multiply 3 and 2, you get 6, so that would be x to the sixth. And I also expanded it here so you can see why that is. So when we square something, we multiply it by itself. If we were cubing it, we would multiply it by itself 3 times. So x to the third is this right here, and we're just multiplying that by itself. So if we were to add up all these little 1 exponents that are there, there's 6 of them. So when you have a power to a power, you multiply the powers. And then with negative exponents, this is probably the trickiest rule, and we're going to go over this in an example later. Negative exponents, there's this rhyme you can remember, cross the line and change the sign. Basically what that is, if you have a negative exponent, whether it's in the denominator or the numerator, it needs to change its position. It needs to, if it's in the numerator, like this example with x to the negative second, it needs to go down to the denominator, and we just put a 1 over it. If we had 1 over x to the negative second, let's do negative third since we already have second. 1 over x to the negative third, to make that a positive exponent, because we always want to work with positive exponents, it would just become x to the third over 1. We flip that, which is x to the third. So with negative exponents, you flip them, you make them positive. So let's do an example of zero exponents. So I see right here, I have y to the 0 power, and I know that is 1. So I'm just going to evaluate that as 1, and I have 6x squared times 1. 6x squared times 1 is just 6x squared. As soon as you see something to the 0 power, you can just drop that whole term, cross it out like that, and then continue evaluating. And we don't have anything to evaluate with 6x squared, so we leave it as it is, and that's our final answer. Now for the power rule. When you have the power rule, you're going to multiply each term by the power outside. So we have 3. Let me just erase that so you can see it. Okay, eraser's not working, so know that that's a 3. So we have our first term, which is 3 to the third power. Now, we know that coefficients keep the normal rules of multiplication and division. They also keep the normal rules of exponents. So we are not multiplying 3 by 3. We are doing 3 to the third power. Let's break this up as 3 to the third power. And now we have x to the fifth to the third power. And we have y to the third power. And we have z to the second to the third power. So that power applies to every single piece of that term. So 3 to the third power is 27. X to the fifth power to the third power, 5 times 3 is 15. So we have x to the 15th. Y to the first to the third power, 1 times 3 is y to the third power. And then we have z squared to the third power is 2 times 3 is 6. We have z to the sixth. And that would be our final answer. So with power rules, when you're raising a power to a power, you multiply. Okay, negative exponents. Remember, negative exponents just have to be moved. If they're on the top, they go to the bottom, and if they're on the bottom, they go to the top. So I see I have one negative exponent right here. It's y to the negative third. Negative 3 can stay the same. Remember, coefficients follow their normal rules. It doesn't matter if we have a negative coefficient. So we have negative 3. We're going to split it up. And then we have y to the third, negative third, and we have z to the fourth. Now, negative 3 and z to the fourth are fine. They're good. Nothing can be combined with them. There's nothing to evaluate. There's no exponents to add, multiply, subtract, whatever. But y to the third needs to become y to the negative third, 1 over y to the positive third. When you have a negative exponent, like I said in the beginning, you need to flip it, cross the line and change the sign. You need to move it from the top to the bottom, or the bottom to the top, and make the exponent positive. So we can always work with positive exponents. Then we still have z to the fourth. So our final answer, we just multiply straight across, and there's ninja ones under both of these we can multiply. Negative 3 times 1 times z to the fourth is negative 3z to the fourth over y to the third. And that would be your final answer. So let's put it all together. You may see problems like this that look pretty complicated, but are not that bad. So let's just start piece by piece. So we have 8 divided by 4. We have x to the fifth over x to the third. We have y to the third over y to the fifth. And then we have z squared all over z squared. Now we know with division that we subtract our exponents, but we have coefficients here. We're going to treat them with the same rule. So 8 divided by 4 is 2. X to the fifth over x to the third, we subtract those exponents, so we get x squared. We have y to the third divided by y to the fifth. We subtract those exponents. 3 minus 5 is negative 2. So we have y to the negative second. And now z squared divided by z squared, you can already see that anything divided by itself is 1. But also, if you subtract those exponents, you get z to the 0 power, which we know is also 1. So we have 2 times x squared. Nothing needs to happen there. This y to the negative second is going to become, cross the line and change the sign, 1 over y squared. And then z to the 0 power is just going to become 1. So we'll multiply straight across and put it all back together. We deconstructed our puzzle. Now we're putting it back together. We have 2x squared all over y squared. So that whole big messy thing turns into that when you simplify. Okay, here's your hot question. Please evaluate this problem right here, and for the division sign in your hot question answer, just put a slash, and for exponents, put a caret like that. Do your best. If you have questions, write them down, and we will go over this tomorrow in class.